SOLIDWORKS MBD provides an integrated drawingless manufacturing solution which helps you define, organize and publish 3D product manufacturing information (PMI) and 3D model data into industry standard file formats. Manufacturing intricate components with precise fits can be a complex and time-consuming process. Creating drawings takes time, but communicating your design intent clearly and maintaining detailed multi-sheet drawings is more challenging. SOLIDWORKS MBD lets you apply your manufacturing information directly to the model, making it easier to define but also easier to understand. In an assembly like this underwater camera housing, where precise fits are required to prevent water ingress and where these gears need to mesh accurately to control zoom and focus, every part needs to be machined to a very tight tolerance. This can mean high costs, but carefully considered geometric dimensioning and tolerancing can actually lower costs in some cases. So GD&T is not just for close tolerance parts and assemblies, it can be applied to any part. The process of setting up a fully detailed 3D model is straightforward, starting with considering how a part is assembled. This blue gear plate is mounted on the base plate using these two bolts. With this in mind, the gear plate needs to be dimensioned in such a way as to ensure that the gears mesh correctly and the whole assembly works as expected. Taking a look at the gear plate itself, you can see that a couple of 3D views have been set up in advance. This 3D view is set up to show a set of notes that you may have found previously in a title block of a 2D drawing. You can easily bring in standard notes from a text file or from the design library like this. Rather than just being dumb text, you can easily link information such as material into the note just by selecting it from a convenient drop-down list. This makes these 3D notes accurate and up-to-date, reducing the chance of errors. The first step in detailing this part is to determine where the manufacturing datums are going to be. As the part is bolted to the base plate, this bottom surface will be the primary datum. This bearing board controls the position of the shaft assembly, so it is the second datum. The gear shaft is the tertiary datum and can be defined as a continuous hole as it is drilled in one operation. You can now select which features to auto-dimension, so let's pick the mounting holes, automatically recognised as a pattern, and the rear bearing hole. SOLIDWORKS does all the hard work for you and automatically creates the datums, dimensions and geometric tolerances for the features selected. Those features are now fully defined as seen by the green colour of the surfaces. You may prefer to see these annotations as a list, so you can quickly change to show each of the datums, dimensions and geometric tolerances like this. Notice that selecting any of the information either in the tree or on the screen highlights the corresponding model geometry, a big advantage over interpreting a 2D drawing. If you flip to a top view, you can see the mounting hole dimension has automatically recognised there are two holes. The location of these holes needs to be detailed, which is easily done by recreating the basic dimensions. The 3 and 4 dimensions have been created in a different view than the top view that we wanted. This can easily be fixed by flipping them into the top view. You can now see the result and quickly tidy up the dimensions to make the top view look just right. All the information needed for these mounting holes is complete, so you can snapshot this as a 3D view. You can include annotations from other views as well, but in this case we just want what we can see here. The next step is to detail this front view. You can add a vertical dimension to define the position of this rear hole. All the information needed for now is there, but notice how you can easily flip the arrow direction to make the diameter dimensions look right. You can now capture this front view and it appears in our thumbnails at the bottom of the screen. Whilst in this orientation, you may also want to dimension this pattern of holes around the bearing bore. In this case, we can use the plus-minus scheme rather than the geometric tolerancing scheme used before. SOLIDWORKS recognises and highlights all 6 holes as a pattern. When complete, SOLIDWORKS has automatically added the required information for the holes, including depth and countersinking values. All the information for the bearing bore, rear bearing and hole pattern is now available in one view. It may be preferable to have the newly created hole pattern information on a different view, and this is also easy to do. Simply create a new view and select the hole pattern information to go onto it. You can now snapshot this view and just include the hole pattern information. 3D views help you capture the correct orientation and dimensions for displaying manufacturing information for specific features or for manufacturing operations. Let's now take a look at this right view. Straight away you can capture this view and start to add dimensions. This width dimension needs to take into account both of these separate surfaces. It is easy to define this and ensures that the correct geometry highlights when you select the dimension. SOLIDWORKS also lets you control the display of tolerance information, and we will set this dimension to show limits. You can continue to dimension the part quickly and easily, adding this location dimension, this height dimension, and this material thickness dimension. For this angled surface, you may need to dimension to the intersection rather than the edges. This is easily catered for using the intersection dimension tool. The resulting dimension can be normal to the origin, vertical, horizontal, or even normal to another reference like this. In this case, we will leave it horizontal. It is also very quick and easy to create size dimensions, such as this fillet, or even this chamfer. SOLIDWORKS automatically details these to the correct standard. Flipping back to the 3D view, you can tidy the dimensions up, noticing that the arrows on this dimension flip automatically to fit. In many cases, designers have already created sketch dimensions or feature dimensions in the model that could be reused, saving time and effort. These feature dimensions can be temporarily shown and then captured in your 3D view. All you need to do is select the ones you need and then flip them into the correct view. You can then hide what you don't need, and the position of these gear locations looks good. Capturing this view adds it to our 3D view thumbnails at the bottom of the screen. The part is now coming along nicely, and we just need to detail these two holes on the inside flange. Traditionally, you would set up a new section or detail view in a 2D drawing requiring interpretation, but here we can do everything straight in the model. Creating sections in SOLIDWORKS is easy, and you simply reorient the model, turn off the front flange holes and capture the new 3D view. Before finishing this view, let's take a quick look at some of the options that SOLIDWORKS gives you to control how the model looks. You have all the settings you would expect to control drafting standards, dimensions and arrows. You also have control over default tolerances and how hole callouts are displayed. This option lets SOLIDWORKS automatically create the location dimensions that we were manually creating earlier. You can now add a dimension, and SOLIDWORKS automatically understands that there are two identical holes on this face. Adding a positional tolerance to these holes completes the information needed for manufacturing. And notice that the location dimensions have now been added automatically. Our ISO view contains all of the dimensions created up to now. This can look a little crowded, but a great way to interrogate the model is to use the patent-pending Dynamic View Annotation capability. This automatically fades dimensions in and out as you rotate the model. It is now really easy to understand the design intent of the model. Many companies make excellent use of configurations in SOLIDWORKS to define multiple variants from a base design. This design contains 4 variants, including this longer, lighter version. Traditionally, you may create another separate 2D drawing to detail this part. With SOLIDWORKS MBD, it is easy to copy the existing dimensioning scheme from the original version, and the detail for this right view is updated automatically. Notice that the redundant dimensions for the chamfer and the angle face are highlighted so you can easily remove them. Capturing this view for the new variant completes our task, and we can turn our attention to publishing all this rich information for others to use. Many companies rely on e-drawings to convey product information, and you can easily publish SOLIDWORKS MBD into this format. You can choose whether to include some or all of the configurations, and SOLIDWORKS takes care of the rest. eDrawings also allows you to view and manipulate all of the 3D views created earlier. Selecting a dimension highlights the geometry references, making it very easy to understand the model without the need for a 2D drawing. Many companies communicate information using the PDF format. SolidWorks MBD allows you to publish all of the rich manufacturing information to 3D PDF in a simple and repeatable manner. SolidWorks MBD comes complete with a library of PDF templates that you can easily customize, or you can, of course, create your own for both assemblies as well as parts. This example shows a main graphics window along with 3D view tabs along the bottom. The text boxes along the top are automatically populated with custom properties directly from SolidWorks. This field will become an editable text box within the PDF. This gives others, such as suppliers, the chance to add comments before saving and sending back to engineering. You can also include standard notes or other company-specific details in any format you choose. When you publish a 3D PDF, you simply choose a template and select which standard views or 3D views to include. You can also view the custom properties which will be passed directly into the PDF. When you view the 3D PDF, you can see the values for the custom properties are automatically populated. All of the 3D views previously created in SolidWorks are, of course, available. You can see how easy it is to navigate the design and extract the information needed. Selected dimensions also highlight the reference geometry, making it easy to see which dimensions belong to which faces, removing any ambiguity. As a supplier, I can add comments to the text field before saving and sending back to engineering. This simple capability can really help collaboration with the supply chain. All this means that creating 3D PDFs is both fast and flexible and reduces the common errors associated with interpreting 2D drawings. Going back to the assembly, you previously saw a couple of the existing 3D views. The right view already has a couple of dimensions showing the position and spacing of these large gears. Notice again that selecting this 36 dimension highlights the outer faces of the gears. You can easily add another dimension from the front of the drive shaft to the gear axis like this. Being able to annotate assemblies like this means you can pass on critical information quickly and easily without creating a new 2D drawing. Before publishing this assembly, you may also want to include an exploded view to enhance understanding of how the parts fit together. When capturing a 3D view, you can select a configuration, in this case the exploded view, and also a display state which shows our gear plate component as glass. You can publish to 3D PDF, but this time let's choose a more appropriate template. This template also includes custom properties straight from SolidWorks, but also invites you to enter some text before creating the PDF. Just like the gear plate example earlier, all the 3D views are available, and the dimensions highlight the related geometry. The custom properties are also shown along with the text entered just now. With an assembly PDF, you also see an accurate bill of material. Selecting an item in the table highlights in the 3D graphics area, making understand the product much easier. This also works the other way around. Selecting a 3D part highlights the component in the table. As with the gear plate PDF, you have the ability to enter some relevant information directly into the PDF before saving and passing on to a third party. SolidWorks MBD provides easy-to-use tools for the creation, organisation and output of product manufacturing information and really helps streamline production, cut cycle times and improve product quality.